Hello, and welcome to drillingcontractor.org. This is Kelly Ainsworth at the SPE Annual Technical Conference in San Antonio, Texas. Exact Downhole Telemetry is showcasing their acoustic telemetry network, and I'm here with Andy Hawthorne, Director of Solutions for Exact, to learn more about it. How are you doing today, Andy?
Oh, very well, thank you.
Could you give us a brief overview of the acoustic telemetry network and how it works?
Actually, if you look at the screen behind us, you can actually see a demonstration of how this actually works. So basically what you have is a system that enables you to transmit data through any type of drill string or work string. So irrespective of the operation that you've got going on a well, whether it be casing, completing, cementing or drilling, you can still get data from downhole, which is quite revolutionary because at the present time in deep water, you're really only getting real-time downhole data when you're drilling ahead, which may be less than 15% of your entire rig operations. So basically what happens is we have a tool that you can pick up that actually installs inside the drill string. And we do this and it matches the drill pipe, so it takes a very short time to pick these up, so it's very unobtrusive to rig process. And it sends acoustic data through the wall of the drill pipe with no modification to any of the tools or the drill string or anything else. So it passes data from one tool to the next tool to the next tool as a network back up to surface, and then it records that data at surface by a device called, we call it the ear because it's listening, but that is also wireless and it clamps to the frac head or the cement head or to the quill of the top drive depending on the operation, and that wirelessly transmits to our laptop. Once you've got the data there, you can actually integrate with any of the other rig systems and therefore provide this data both offshore and onshore or wherever the data needs to be. Now the unique thing about acoustic telemetry is it's completely depth independent, formation independent and flow and fluid independent. So almost all telemetry systems that exist at the current time rely on one of those being accepted. So for instance, mud pulse telemetry, which is the common cause for drilling ahead, actually only works when you're pumping and the pipe is full. And also it degrades with depth. So we have a system here that it doesn't matter what fluid is in the hole, it doesn't matter whether you're flowing, it doesn't matter what you're actually doing at all, and it's also independent of depth. So whether you're at 50,000 feet or 15,000 feet, your telemetry rate is exactly the same. So this is a unique breakthrough for the industry.
And the system was recently used in a deployment where you helped an operator whose BHA was stuck in a circulating position. Can you tell us about that deployment and some of the time savings that were achieved there?
Okay, that's a very interesting question. So we were actually out on a deep water frac pack in the Gulf of Mexico. So obviously these are extremely deep wells. And as I said before, telemetry systems that exist today, you can't use during a frac because you have to pump so much proppant through these tools. So because the tool is actually fully through bore, you can actually pump all these proppant and still get data. And you can also get data while the BOPs are closed, which you need on the frac pack. So in this particular job, we'd got down to actually doing the fracking operation, and we'd picked up to the reverse circulating position to actually spot the frac fluids into the drill string. And when going back down to the circulating position, the pipe got stuck. Now this causes a problem because there's only a limited amount of things you can do once this pipe is full of frac fluids. And so what you tend to do then is rely on the surface measurements. And the surface measurements will tell you have a safe margin that you can pull at surface before you actually part some of the thin pipe that's involved in these fracking operations. So they looked at that and they started pulling to that safe limit. Now, the problem is you can't really go past that safe limit. If you go past that safe limit, you're in danger of leaving your completion string in a hole. And that causes something like anywhere between 5 to 3 weeks of downtime or NPT, and may actually cost you the entire well. So the savings are huge. Now what they did in this particular case is, because we have the downhole measurements in terms of weight and tension, you could see when you were pulling on surface what the effect was downhole. And you could see that the model was actually wrong on how much weight was being applied downhole or how much tension was being applied to the string. So this allowed them to actually pull another 10 or 15% on surface while controlling it by actually knowing the value downhole, and safely pull to the maximum limit of the string rather than the estimated model maximum. And therefore they actually came unstuck in this particular case, and obviously the client was very happy.
In another job, you helped the operator verify the TCP valve position. Could you tell us about this operation and some of the results that you saw during that?
Okay, that's again another application here. Say this was a deep water perforation job prior to a frac, and there are numerous multi-stage valves downhole. Now this dictates which direction the flow is going. Is it going partly to the annulus? Is it going up the bore? Is it in reverse circulating position or whatever? So knowing the positions of these valves is quite important. Now on this particular job they actually did the perforation in the TCB gun run, and there was no indication on surface that the perforation had actually worked. So this is actually a dilemma. What do you actually do then when you get into this situation? Now, was it possible that the valve was closed? Yes, it is. Maybe you're pressuring up against the valve to actually do this and there was no activation. But we had sensors below and above the valve. So you could see what the annular and the bore pressure solutions were above and below the valve, and you could immediately tell, and you can immediately troubleshoot which position the valve was in. You could also actually tell by repressuring up that the guns had actually fired. And you could actually see this downhole. So again, this saved them a numerous amount of time in troubleshooting, and it's probably the first time in the industry that we've received downhole pressures from underneath a closed valve during a deep water perforation as well, which can give some insight into the reservoir conditions. So this is another great cost saving in terms of efficiency for the operator in these deep water operations.
Well, thank you for joining us today, Andy, and telling us about the technology and some of the recent jobs you've done.
Thank you very much.
And thank you for joining us on drillingcontractor.org.